Namaste one and all. Welcome to the playlist of Analog Electronic Circuits, course code BEE303. My name is Arvind Joshi. In this session, let's we discuss about clamper circuits. This clamper circuit will come under module 1 of your subject called Analog Electronic Circuits. Before this topic, there is another topic, clampers, that I'm going to complete in the next class. In this class, let's understand about clamper circuit and with some examples also. First theoretical concepts I'm going to explain and some few examples I'm going to solve. Okay. Now let's get into the clamper circuit. First, what do you mean by this clamper circuit? The circuit which is used to add a DC level as per the requirement to the AC output signal is called clamper circuit. The meaning of this, nothing but there is an input AC signal, there is an output AC signal. Here the role of this clamper circuit is it will going to add some DC voltage level. So as per the requirement, it will going to just add, for example, 5 volts, 10 volts DC voltage, it will going to add for the AC output signal. That is the definition of this clamper circuit. And what are the components we are going to use in this clamper circuit? Mean the capacitor, diode, resistor are three basic elements of a clamper circuit. The clamper circuit also, as name suggests, it is a restorer, clamper, adder, okay, or DC inserter. Okay, these are all the different names of this clamper. Okay, and what are the different classifications or types are there in clamper circuit? Is nothing but positive clamper and negative clamper. Now, let's get into the in-depth concept about clamper circuit. We know tau is equal to time constant. Tau is equal to RC. R is nothing but resistor. C is nothing but capacitor. Whenever tau is double lesser than pi, pi is nothing but 0 to pi, the time duration during positive half cycle, pi r t by 2, both are same. Okay, pi, it's the condition. For example, during 0 to pi, in that time, the capacitor will going to charging, okay, charge. But in the discharging condition, whenever diode will going to act as an open switch, in that time, the diode, the capacitor will going to discharge. But here, 5 times tau, double greater than pi, means whenever pi to 2 pi, there is a AC signal from 0 to pi, for example, from 0 to pi. This is the AC signal. This is a AC signal. P, x-axis T. This is input. Input voltage, AC input voltage, 0, pi, 2 pi, 360 degrees. Pi is nothing but 180 degrees. Okay. From 0 to pi, it is a charging condition. Okay. Now, from pi to 2 pi, it is a discharging condition. During this discharging condition, our tau should be 5 times tau. Tau should be multiplied into 5 times. Why? Because here our diode will going to act as a DC supply and it should maintain during discharging condition. It should maintain or it should on the diode during negative off cycle also. It should on. Diode should not off during negative off cycle because of this discharging capacitor. Discharging capacitor or because of this capacitor during negative off cycle also, it should maintain some voltage level, plus minus. This plus minus symbol will going to differ. It will going to change with the, in the according to the position of diode. If in case diode is like this, it is same plus minus. If in case diode is like this, the capacitor direction will going to change minus plus like this. Okay, I'm going to discuss about these topics in future slides. And tau is equal to RC is to be very large. by selecting how it should be very large by selecting R and C large value. Okay. Now let's get into the next slide. There are some few points about to analyze the clamper circuit. In the first step is very simple. The first step is here start the analysis of a clamping networks by considering that part of input signal that will forward bias the diode, whether it may be positive off cycle or negative off cycle. Here our diode should be on. Okay, that's it. Positive is connected to positive, negative is connected to negative. If in case diode is reverse, negative is connected to negative, positive is connected to positive. If the first case is you should analyze the diode, it should be on, whether it may be positive cycle or negative cycle. No need to worry. Okay, like that, you should analyze the circuit. And then second step is during the period that diode is on, whenever diode is on, the first step is it should on. The second step is whenever diode is on, assume that the capacitor charge up instantaneously to a voltage level determined by the network. This means very simple. Whenever diode is going to on, in that time the capacitor is going to charge. Assume that during the period when diode is in the off state, that capacitor will hold on its to its established voltage level. It means whenever diode is going to on, for example, during whenever the first case is diode should be forward bias, whether it may be positive off cycle or negative, okay, negative off cycle. In case diode is on during positive off cycle, in the negative off cycle, diode will go to off. In that time, the discharge will going to take place. In that time also, diode na on ಆಗಿರ್ಬೇಕು ಅಂತ ಹೇಳಿದ್ರೆ, here the tau ಅಥವಾ capacitor is going to play very important role in order to maintain some voltage during diode off condition. Okay, throughout the analysis, maintain a continual awareness of the location and reference polarity for V0 to ensure that the proper levels for V0 are obtained. Keep in mind the general rule that the total swing of the total output must match with the swing of input signal. For example, this is a AC signal input supply. AC signal input supply, TV, everything is remaining same input. The output should be equal to input like this. If in case output will come like this, it should be equal to input. For example, this is a 2 Vm, 2 Vm. This is also 2 Vm. Input is whenever input is 2M, 2 Vm, output also should be 2M. 2 Vm means output swing is equal to input swing. That is the important point. Next slide. Now, let's get into the first concept here. Listen very carefully. First concept, negative clamper. Here, negative clamper. Here, the positive is connected to positive of the diode. Negative is connected to negative of the diode. Okay. Positive is connected, positive of the diode. Negative is connected, negative of the diode. Means our diode will going to act as a on condition, or diode will going to act in the forward bias. Means here our diode, what is the first step? Diode should be on. Here obviously diode will going to on during positive off cycle. Why? Because positive is connected to positive, negative is connected to negative. So our diode will going to act as a on condition. Our diode will going to act as a short circuit or closed switch. Assumption, it is an ideal diode. There is no threshold voltage. Tau is equal to RC should be very large. How it should be very large? Here we need to select R and C value very large. During positive off cycle, obviously our diode will going to act as a closed switch. During short circuit condition, what is the output voltage? Output voltage is equal to 0. Why? Because during short circuit condition, current will be more. Voltage will be ideal case 0. Here V0 is equal to 0. And then, dear students, please apply the KVL for this loop from positive to negative. You will going to get VI means minus to plus VI, plus to minus Vm, minus Vm, and plus to minus, minus V naught, is equal to 0, Here V naught is equal to 0, What will going to come? Vi is equal Vi minus Vm, is equal to 0. Means I need Vi is equal to Vm. Vi is equal to Vm. Okay, this is the equation for input voltage. Vi is equal to Vm. Capacitor acts as a battery of the voltage Vm. Vm is nothing but a capacitor voltage. Vm or Vc. You can take anyone for your convenience. I'm going to take here Vm. Okay. Now let's get into the another slide. Okay. I think all of you understand during positive off cycle. Now negative off cycle. During negative off cycle, I'm going to change only the polarity of input voltage minus plus. Here our diode will going to act as a Y, because for minus is connected to plus, plus is connected to minus. So that's why our diode will going to act as a open switch. During open switch, please apply the KVL here. Here you need to apply from positive to negative. Positive minus to plus, Vi. Next, minus to plus, V naught, minus to plus, Vm is equal to 0. I need only V naught. V naught is equal to minus, you need to take here, is equal to, just as it is, you need to write here LHS is equal to RHS. Change the sign for minus Vi minus Vm. Here we know the equation already for input voltage. Vi is equal to Vm. Substitute here, my Vi is equal to Vm. Substitute here, or directly take down minus Vi, take down the common here, minus Vi plus Vm. Substitute Vi is equal to Vm minus Vm plus Vm is equal to minus 2Vm. Minus Vm plus Vm minus 2Vm. Okay. Now, I think all of you understand about during negative off cycle. Please consider previous during positive off cycle equation, like Vi minus Vm minus V naught is equal to 0. Okay. Here I need only output equation. V naught is equal to Vi minus Vm. Okay. With the help of this equation, we can write the waveform. Okay. How we can write? Just observe here. In the in the input supply, we have three conditions, like Vm maximum, 0, 0, minus Vm here, minus Vm. Okay. Whenever Vi is equal to 0, apply here Vi is equal to 0. What will going to come? Minus Vm, Whenever minus Vm, apply here, minus Vm, V naught is equal to minus Vm is equal, minus 2Vm, Whenever Vi is equal to Vm, minus Vm, 0. Okay. I think all of you understand. Now, how to write the graph? Please check here. Whenever Vi is equal to 0, where is Vi? Here Vi is equal to 0. Output is what? Minus Vm. Here minus Vm is there. Just copy here. Minus Vm. Next, whenever minus Vm is there, Vm, you take Vm, output is 0. Whenever Vm is there, output is 0. Okay. Next, you need to take just here up to here. Next, whenever minus Vm, here minus 2Vm. Here is minus 2Vm, here minus 2Vm. And then write down. Like this. Like this, you need to write the waveform. Okay. Now, previous we discussed about square waveform. Now let's discuss about sine waveform. Here sine waveform, whenever V naught is equal to, whenever Vi is equal to 0, the output is V naught is minus Vm. Correct. Whenever Vi is equal to 0, V naught is equal to what? V naught is equal to minus Vm. Whenever minus, what is the equation? V naught is equal to Vi minus Vm. Whenever Vi is equal to 0, in the term minus Vm. Whenever Vi is equal to Vm, answer is what? 0. 0 is 0 condition. Okay. Next, whenever minus Vm, okay, minus Vm, minus 2Vm. Where is minus 2Vm? Here, minus 2Vm. What is the increased voltage from here to here? Extra DC voltage it is going to add. Okay, this is how our input and output waveform we should write. Okay, I think all of you understand about this concept about clampers. Now let's get into the here. This is a negative clamper. Negative clamper means what? It will going to clamp in the negative cycle. This is a positive above 0. This is a negative. Okay, now next, positive clamper. Here positive clamper, just change the polarity of diode, plus minus minus plus. Here how our diode capacitor polarity should be there, plus minus, depending upon this capacitor, plus minus, here also plus minus. Okay, this is how I'm going to write the positive clamper circuit. During positive off cycle it will going to act as a open switch, but during negative off cycle it will going to act as a closed switch. Minus is connected to minus, plus is connected to plus. According to our steps, we need to take diode should be forward bias in during first step. Okay, how it will going to forward bias? We need to take down the negative off cycle. Negative off cycle, it will going to act as a closed switch. We need to, anyhow, we should close the switch. We should on the diode. Okay. Now, during negative off cycle, our diode will going to act as a closed switch. And then for this condition, you need to apply the KVL. We know during short circuit condition, V naught is equal to 0. And we know the how to apply KVL, minus to plus Vi. Next, plus to minus Vm is equal to 0. Vi is equal to Vm. You will going to get. During positive off cycle, positive, negative, our diode will going to act as open switch. You need to apply the KVL, plus to minus Vm, minus to plus V naught, plus to minus Vm is equal to 0. V naught is equal to what? Vi minus, sorry, Vi plus Vm. We know the equation for Vi is equal to Vm here. Vi is equal to Vm. Just substitute here. Vm plus Vm, that is nothing but V naught is equal to 2Vm. Just concentrate on this equation. V naught is equal to Vi plus Vm. Whenever Vi is equal to 0, this 0, what is the output voltage? Vm. Just write here Vm. Negative, not minus Vm. It is a positive Vm. So that's why I'm going to write here my plus Vm. Next, whenever Vi is equal to Vm, Vm plus Vm, 2Vm. Where is 2Vm? Here 2Vm. This is normal Vm. 2Vm means double. Okay, I'm going to write here to here. Next, here to here. Next, whenever Vi is equal to minus Vm, output is 0. Just 0. Repeat. Okay, this is above the 0 reference, means it is a positive clamper. It will going to add during positive cycles. Okay, now I think all of you understand about positive clamper very easily, because negative clamper little bit complicated than positive clamper. Whenever, if you understand negative clamper, positive clamper is very easy. Okay, now listen carefully. Now, very important question. Addition of battery in clamper. It is a, without any reference, it is like positive clamper. But here there is a reference. It's already positive clamper. It will going to add during positive off cycle. But in the negative off, but here there is a reference. First, I'm going to assume diode will going to act as a closed switch during negative off cycle, because during positive off cycle it will going to act as a open switch. But what is the first step? Here we need to make diode on. So that's why minus plus. In that case, our diode will going to act as a closed switch. Whenever diode will going to act as a closed switch, V naught is equal to 0. Obviously, we know. Please apply the KVL, plus Vi plus minus Vr minus Vc is equal to 0. Vc is equal to Vi minus Vr. Vc is equal to we know the equation Vi minus Vm. Vi, you need to substitute Vi is equal to Vm. Here, during previous analysis, I took Vc, Vm for across capacitor voltage. Here I take Vc, both are same. You can take any value. Okay, for convenience, I'm going to take here Vc. Okay, because Vm is nothing but input voltage, so that's why I take this one. And positive of cycle, our diode will going to act as a open switch. Please apply the KVL, minus plus to minus minus. Apply like this, plus to minus, minus to plus plus Vi, minus to plus plus Vc. I just interchange here. Please make it correct. Vi plus Vc minus V naught is equal to 0. V naught is equal to, you take this one to LHS, and this is remaining in the RHS. Remaining same in the RHS, Vc plus Vi. You can substitute here. Vc is equal to Vm minus Vr. Vc is equal to Vm minus Vr. Vc is equal to Vm minus Vr, and remaining same Vi. Okay, just substitute. Vi is equal to Vm. Vm substitute madi. So 2 Vm minus Vr. Whenever Vi is equal to 0, what will going to come? 0 means Vi. Whenever Vi is equal to Vm, Vi. Whenever Vi is equal to Vm means 2 Vm minus R. Whenever Vi is equal to 0, Vm minus R, Vr. Whenever minus Vm plus Vm will going to get cancelled. So we minus Vr will going to remain. So how to write the waveform? Whenever Vi is equal to 0, Vm minus Vr plus Vm minus Vr. So here plus Vm minus Vr. Next, whenever Vi is equal to Vm means here V naught is equal to 2 Vm minus Vr. Whenever Vi is equal to V minus Vm means here, what is the output voltage? Minus the reference voltage is here. Like this, you need to apply the KVL and get the answer and write down the input and output waveform. I'm going to erase everything. Now, let's solve one problem. Listen carefully. It's a very important problem for your VTU examination. Using ideal diode, design a clamping circuit to perform the function as in figure. They are going to mention one input sign, input supply plus 20 minus peak to peak 20 volts. Clamper output should be plus 30 minus 30 minus 10 plus 30 during positive off cycle, during negative off cycle minus 10. We need to write the circuit diagram for this one. Okay, what is the input voltage? Input is here, capacitor here. Where is the clamping will going to occur during positive condition in the positive cycles. So that's why it is a positive clamper. And then there is some reference here, minus 10. You need to take minus 10. So, and then output voltage. You need to just, here they will going to mention input and output waveform. You need to write the circuit diagram. It's very, very important. It's the biggest, toughest task. Here it's look like very simple, but in the examination, you will not going to get the proper explanation or the proper understanding. So that's why please practice this problem. This problem is very, very important. This kind of problem they will go to ask. Okay, very simple. Just think positive and take down this problem. Very simple. Here I'm going to explain another one time. Here there is a input signal plus 20 minus 20. Very simple. Next, it will going to apply to the clamper Vi. Yes, of course it is a Vi. Here output will be there. They will going to just mention this much only. Okay, output plus 30 minus 10. Without this one, it is a, obviously it is a positive clamper. Okay, but here there is a minus 10 reference. So that's why it is a positive clamper, but additional DC supply will be there. Okay, what is the, here we need to take positive clamper, but additional DC supply you should add at least 10 volts, at least for 10 volts. Okay, as per the output waveform. Now, I'm going to take during negative off cycle, it is going to conduct. So that's why I will going to consider first negative off cycle. Apply the KVL Vi minus Vr minus Vc is equal to 0. Vc is equal to Vi minus Vr. Out of the KVL, I think all of you know. Plus to minus, sorry, minus to plus Vi minus Vr minus Vc is equal to 0. Vc is equal to Vi minus Vr. 20 minus 10. You need to substitute Vi is equal to 20 minus Vr is nothing but minus 10. Sorry, minus 10. Total Vc is equal to 10. During negative positive off cycle, diode will going to act as a open switch. In that time, you need to apply the KVL V naught minus to plus V naught minus VC minus VI is equal to 0. We need only V naught is equal to minus will going to act, we need to change to plus VC plus VI. V naught is equal to substitute here. VC is nothing but 10. VI is nothing but 20. 20 plus 10, 30. Okay, this is the one method of solving the problem. And then another method is whenever VI is equal to 10, VI is equal to minus 20. We know the equation V naught is equal to VC plus VI. Substitute here, VC is equal to, VI is equal to 20, VC is equal to 10. We already know VC is equal to 10 anta. So that's why 10 plus 20 is equal to 30. V naught is equal to VC plus VI. Whenever VI is equal to minus 10, minus 20, 10 minus 20 is equal to minus 20. Whenever I is equal to 20, output is 30. Whenever minus 20, output is minus 10. Very simple. Whenever 20, 30. Whenever minus 20, minus 10. So that's why we need to solve the problem. I think all of you understand about the problem. Very simple problem. They will going to ask 8 marks for 8 marks. Now, second problem, very simple problem. Here, during previous case, it is ideal diode, but here there is a threshold voltage. So very careful. Threshold voltage will be there. Input voltage is here. They will going to mention the circuit diagram. It is what is the circuit diagram? Negative clamper. Input plus or minus 12 volts. Okay. Now let's see understand this circuit diagram. During positive off cycle only, it will going to act as a closed switch. During whenever diode will going to act as a closed switch, V naught is equal to 0. Please apply the KVL. How to apply the KVL? Plus to minus. So minus to plus. Yeah, this is how you need to apply. So minus to plus VI minus VC minus VK is equal to 0. Substitute here 12, VI is equal to 12. We know minus VC, we don't know VC. VC minus 0.7 is equal to 0. VC is equal to 12 minus 0.7. VC is equal to 11.3. During negative off cycle, our diode will going to act as an open switch. Apply the KVL minus to plus VI plus V naught and plus VC is equal to 0. We know V naught is equal to minus VI minus VC. V naught is equal to substitute here minus 12 minus 11.3 total minus 23.3. This is how we need to solve the problem. During positive off cycle, 11.3. During negative off cycle, minus 23.3. Whenever Vi is equal to 11, V naught is equal to 0.7. Whenever Vi is equal to minus 12, output is minus 23.3. Whenever Vi is equal to 12 is nothing but during positive off cycle, output is 0.7. 0.7. Whenever Vi is equal to minus 12, output is minus 22.3. 22.3. Okay. And then whenever unit during positive off cycle, it will going to give 11. Minus 11.3. Total swing is 24 volts plus 12 minus 12. Total 24 volts. Okay. Here 12.3 from here to here 12.3. Here 0.7. Total 23.3 plus 0.7. So here to here 23.3 plus 0.7 total 24 volts. 24 volts swing. Here also same plus 12 minus 12 total 24. Here also total 24 swing will be there. What is the condition? What is the definition? Total output voltage swing is equal to total input voltage swing. This is how we need to match. Okay. Very simple problem, alva. Now let's we understand very important problem. Very important problem. Here, determine the output voltage for the clamper circuit. Please understand very carefully. They will going to mention the input sine waveform plus 15, minus 25, T1, T2, T3, T4, T5. Very simple. 0 to T1, positive off cycle. T1 to T2, negative off cycle. T2 to T3, positive off cycle. Understand very carefully. Okay, positive off cycle from 0 to T1. Very careful. Minus negative off cycle T1 to T2. Okay. Now, it is a which kind of, without any reference, which kind of clamper circuit? It is a positive clamper circuit. We know during positive off cycle only it will going to give the waveform. Okay. We need to make diode on. During negative off cycle it will going to on. So that's why I'm going to consider it is in a negative off cycle it will going to act as a closed switch. Okay. During negative off cycle minus will connect to minus, plus is connected to plus. Our diode will going to act as a closed switch. Closed switch. and then apply the KVL, minus to plus, plus V naught, and then minus 4 volts, VR is equal to 0, output is equal to 4 volts from which cycle? Negative half cycle means what? Year to year, T1 to T2. Listen carefully, T1 to T2. For T2 to T3, diode is reverse bias. T2 to T3 means positive half cycle. You need to neglect from 0 to T1. You need to take from T1 to T2. Why? Because during negative half cycle only diode will going to conduct. Okay, during negative half cycle, we need to consider only um, this condition, and then during positive half cycle, you need to consider from T2 to T3. Diode will going to act as an open switch. Apply the KVL, minus to plus, minus plus 20 V naught across capacitor, plus to minus, minus 29, minus VI is equal to 0. Substitute here the values. VI we know 15 volts, VI plus 29, total 44 volts. We know the equation for tau. Tau is equal to RC. We know the value. Here they will going to mention 100K. C is going to 29. Okay, substitute here. Sorry, 1 microfarad. 1 microfarad. Total 0.1 seconds. Total discharge time 5 times. We need to take whatever here come. You need to multiply 0.1 into 5. 0.5 second during negative half cycle. During positive, sorry, during charge condition, it will going to act as it will going to show in the 0.1 second. During charge condition is 0.1 second time it will going to take to charge. During whenever it will going to discharge, means diode should be off during positive half cycle. That is means it will going to take 0.5 second. Means apply the KVL to the loop. Okay, plus VI, and we know the equation. Apply the KVL to the loop. Which loop? You need to apply the KVL for this loop. Minus to plus VI, minus to plus V 4V, and plus to minus VC is equal to 0. We know the value of VI and 4 value. 4 already I take reference value 4 volts. VC is equal to VI 25. Sorry, VI 25 during negative half cycle, during minus 25. So you need to take 4 volts input. Already I take VI means plus 25, total 29. Okay. Now capacitor holds its entire charge and remains charged at 29 volts. 29 volts. You need to write the graph. First, during 0 to T1, I'm not going to consider anything. During T1 to T2, negative half cycle, output voltage is 4. 4 you need to take during T1 to T2. Whenever T2 to T3, what is the output voltage? 44. You need to take 44. Same. It will going to take same. Okay. Whenever charge condition, it will going to take 0.1 second. Whenever discharge, it will going to take 0.5 second. You need to show a little bit larger. Okay. This is how you will going to analyze the circuit. This problem is very, very important. Maybe this type of problem are will going to ask in the examination. Okay. Yes. Very, very important. Similar kind of problem you can solve. Take down the example problem. Take down the example problem. Similar kind of problem. Everything is remaining same. V naught is equal to 5. Vc is equal to plus 5 plus 20, 25. V naught is equal to 35. You need to consider here 10 minus 20. You need to write down the waveform. Everything is remaining same. Everything is same. Okay. What we discussed in the last time. Thanks for listening. Thanks for listening.